Hey everyone, in our last video we covered finding the determinant of a 3x3 system of linear equations. But what if you actually wanted to solve that? And to solve that, you'd have to just invert the matrix. What you do is you take matrix A, invert it, multiply it by B to get your vector of x's. Then that's the solution. So how exactly do you invert a 3x3 system? Well, this is the method I like to use. You have to get the determinant first of all, and you need to multiply by the adjunct matrix A. So to get that adjunct, what you do is you find the minor matrices that we found before, and you have to find that and make it into a separate matrix. And remember, you have to remember the cofactor matrix as well. If you multiply by the wrong symbol at the wrong time, it'll mess up everything. Let's go back to our previous example. Let the A matrix be this. And what you need to do is you just have to reform the matrix using the minors. So we need to get all of these positions filled. For the first one, we end up just it's like finding the minor. It's like converting each one of these into a 2x2 matrix and finding the determinant and putting them into the cells of this separate matrix, which we'll use in this equation. So for this one, you put your hand over that, the column and the row, and you just find the determinant like you would a 2x2 matrix. So for that one, you'll have 6, 7 minus 6, 8. So that's one example. And then you just do that for the rest of them. For this one, you need to put your hands like so. And that one will end up being 3, 7 minus 2, 8. And you repeat the procedure until you have this filled out. Then what you can do is you can just plug in this. This is not a matrix, it's just a scalar value. And you just multiply that into all of the elements in this accompanying 3x3 matrix. And from that, you'll have the inverse of the matrix. So I'm not going to finish this problem because I gave you the tools to finish it, but let's see what the final result would actually look like. And as I said earlier, I am a big fan of MATLAB. It's really useful for dealing with the matrices and any kind of matrix operation. So we let A be that matrix. And then, yeah, MATLAB is so powerful. There's so many ways you can invert it. Whoops. And boom. So do it yourself, and you should be able to get this result as the inverse of the matrix. So when you have this problem, you'll also have a matrix of constants, and you just multiply the inverse of the matrix by that example to get actual solutions. So what would the problem look like before you even make the matrix? Usually, I guess, for high school students, you probably would see more of x, y, and z. Like, the system of equations you might have might have originally have been like so. And, I didn't actually show you how to put this into a matrix, but after looking at the 2x2 matrix video, you should know how to do it. But this is what it would have originally looked like, something like this. The variables might be different, but... Oh, and these are z's, by the way, it's not 2's. And then you would have had some constants, maybe, So in this case, b would end up being this. So to get the final answer, x, solution, you just multiply them by each other. And it's actually a very clean matrix, not many fractions. And you know the trick I showed you to see if you can, now you're actually multiplying a matrix by a matrix, so you're going to get multiple elements inside of another matrix. Use this trick to make sure you did that right. This is 2 by 1, and this is a 3 by 3 matrix. Cross those out, and you know that X is going to be a 3 by 1 matrix. Okay, so X will be, you get 3 results. How do you get each one of these? You multiply, you find the dot product of this and this. What will it be, for example? Be negative 3 times 10 plus 2 times 0 plus 1 times 2. Okay, so that's how you find the first element in this solution matrix. And you just do the rest for the other ones. You multiply these values by these values. And then the last one you do these values by these values. So it's just that times that plus that times that plus that times that. It's not like multiplying 2 brackets where you have to do each combination. No, just the first one by the first one, second by the second, third by the third. Simple as that. And yeah, we can even find the actual solution, and you can double check by hand to see if you received this result. Let's call the B matrix as... Okay, and this times B. And these are your solutions. Negative 32 for X, negative 24 for Y, and 30 for Z. So if you are dealing with like a physics problem or something that has to be realistic, you know, you can tell if your answer is wrong if it's below 0, like, you know, like, ooh, speed, like, or distance or something like that. Or time even, it shouldn't be negative, for instance. So you can see if you made a mistake when you solved it, or if it's makes physical sense if you're dealing with an application kind of problem. And yeah, there you go. And the thing is, when you do this inside of a calculator, you can just do this within seconds by using the matrix operations on the, kind of like I showed you earlier in the 2 by 2 matrix video. So please check out the 2 by 2 matrix video to see how you could do it with a calculator. It doesn't even have to be a graphing calculator. It can be even a standard calculator that has matrix operations on it. You just input in the values for the A matrix and the B matrix, and you can get the calculator to invert it for you. That's why on a lot of pure math courses, they won't allow you to use calculators, but some other courses, like maybe physics, they'll allow you to use calculators because they know that this is just the grunt work. A lot of the times is setting up the problem, that's the difficult part. You have to be very careful when you set it up, and you have to make sure that you're only using reasonable assumptions. But for the grunt work, and if you have to brute force your way through it and solve a 3 by 3 matrix, this is the way to do it. I've even seen a 3 by 3 matrix on many kinds of other tests, like IQ tests even, where you'd have to quickly, where it'd be like, oh, this person is older by this one, but this one is younger than that. You can actually make that into a linear system and solve it if you wanted to go about it that way. Yeah, math is very powerful. So these are just linear operations, though. It can get a lot messier. You can't do this if you have non-linear pieces in your set of equations. Like if it's squared, you can't do that. If you have cos, or if you have logs or exponentials to the variable like 10 to the x, you know, you can't use this method. But if you're dealing with completely linear systems, then go for it. Yeah, I hope you enjoyed this video. If you found it useful, please consider giving a thumbs up and consider subscribing to my channel so that you can be the first one to receive all of my latest and newest videos. Thank you.